So this video is to go over the math review practice reviews that we have covered in chapter 1. So the first thing to do, if you haven't already downloaded the PowerPoint, it's just a 10-slide PowerPoint. It is posted in Moodle. You should see it just above where this video link was. So if you want to either print it out so that you can follow along through, add notes to, it really just might make it a little bit faster for you. My other suggestion is that as we go through each slide, that you listen to the instructions, hit pause, try to do the math, the question itself, and then go back and restart so that you check yourself, see if you know the information, then that way you're going to see if you're doing it correctly. And if you're not sure, then that way you can start the setup as much as you can and then listen to the video so that you can fill in any blanks that you may have. Okay, so first one. So the first one, this is from the very first lecture looking at classification of matter. So in this, the question says identify each example as a pure substance or a mixture. If it's a pure substance, then I want you to identify it as an element or a compound. If it's a mixture, you'll identify it as a homogeneous or heterogeneous mixture. So if it's a pure substance, it's one of these. If it's a mixture, it's going to be one of those. So in this, chocolate cake batter. So once you get cake batter mixed up, you cannot see any bits, but you know that you put oil, you put water, you put eggs, you put the mix together. So it is definitely a mixture, but it looks uniform, so that's homogeneous. Ammonia, NH3. If you see something that's written just as a formula and it doesn't say it's mixed in water or it doesn't say that it's mixed with anything else, then you know that that is a pure substance. Nitrogen and hydrogen in a fixed ratio makes this a compound. Iced tea with lemon. So you know, in fact, iced tea is going to have ice. It is going to have water. It is going to have tea pigments. It is also going to have lemon in it. So that is definitely a mixture. And you can see the differences within it. So that is heterogeneous. Copper. So if you have nothing except just the name of an element, and so copper, Cu, one of the ones that you have to learn, so you know that that is a pure substance, and if it is listed as just copper, not a mixture of copper and anything else, so that is an element. Next big thing that we started talking about is we started talking about unit conversions. And so in this, remember that if you have a base unit as one of the units in the problem, then you're going to do this in just one step. But if you have prefixes, which is kilo, deci, centi, milli, micro, in both of the units of the problem, then remember you're just going to do it in 2 steps. So in this one, 24 liters. Liters is a base unit. So since we've got a base unit in one of the units, we know that it's just a single step. So in this, set it up just like this. Always write out given unit times in a line. You're going to put the unit you start with. Doesn't matter what that unit is. What you start with is always going to go on the bottom. Since this can go in a single step, we can go directly to deciliters. Whenever you see deci, 10 goes in front of it and the base unit gets the 1. It takes 10 deci to make a base unit. So in this, liters and liters cancel. 24 times 10, 240. This one, on the other hand, micro and kilo, this is a 2-step process because both of the units have prefixes. Doesn't matter, we're just going to go to grams in between, then to kilograms. It's not any more difficult. It's just a second step that you have to do. So think of the arrows. Each arrow represents a step. So in this, 97,123 micrograms, the given unit, times in a line. Micrograms goes on the bottom. The unit you start with always goes on the bottom. But in step 1, we need to go to grams first. Micro, whenever you see micro, you're going to put in a million. Micro is a million times smaller. Then, change the color. Second step, now we have grams. So we've got to go from grams to kilograms. So grams goes on the bottom in the second step. The unit that you went to in the first step goes on the bottom in the second step to get it to cancel. And remember with kilo is bigger. The bigger unit is the one that gets a 1, and it takes 1,000 base units to make a kilo. Grams and grams will cancel. So now you're taking 97,123 times 1 times 1. Remember that does nothing. Anything times 1 or divided by 1 is the same thing. So what you're going to do is take 97,123, divide it by 1,000,000, then divide it by 1,000,000 again. So that is going to move 1, 2, 3, 4, 5, 6, 7, 8, 9. So I'm going to end up with 0.00097123. So if you just put in 97,123 divided by 1,000,000, make sure that you double check the number of zeros that you do. You should have 0 point, and I'm double checking myself. 1, 2, 3, 4. I should have one more 0 in that number. Now, if I put this in scientific notation, it will shift it so that I would put the number between 1 and 9. So it would be 9.7123 times 10 to the 1, 2, 3, 4, 5 times 10 to the -5th. So if your number comes up that way, remember the negative exponent tells you the number of decimal places you've moved to. For a number smaller than 0, a positive exponent is a number larger than 1. Sorry, smaller than 1, larger than 1. Next one, milli, micro. 2 steps in this. I need to go from milligrams to grams, then I need to go from grams to micrograms. In the first step, doesn't matter what the number is, you always put what you start with, mg times in a line, mg on the bottom in the first one. In this first step, we're going to grams. Milli means 1,000, grams on top, so milligrams and milligrams will cancel. Now, I need to do one more step, grams on the bottom, micrograms on top. Micro, 1, 2, 3, 4, 5, 6, gets 1,000,000 over 1. Grams and grams can cancel, leaving you with the answer that you want in milligrams, and it's on the top. Now, in this one, 123.27 times 1,000,000 and then divided by 1,000. Okay, multiply everything across the top, divide by each thing that's in the bottom. So in doing this, you should get 123,700. If you were to put this in scientific notation, you would need to move your decimal place from that point and go 1, 2, 3, 4, 5. So it'd be 1.237 times 10 to the 5th. So remember, in this, you'd leave those zeros off. There was no decimal as an initial, so you leave the zeros off, indicating the size, the number, move the number between 1 and 9, so it just helps to shorten the overall size of it. 8.068 centimeters, decimeters, 2 steps. I got to go from centimeters to meters, and from meters to decimeters. 8068 centimeters, my starting point. Centimeters on the bottom, meters on the top, where I'm going in the first step. Centi means 100. Centimeters cancel. That finishes my first step, but I'm not finished. I now need to do the second step, times in one more line, meters on the bottom this time, decimeters on the top. Deci means 10. 10 decimeters makes 1 meter, or 10 deci makes the base unit. So now in this one, 8,068 times 10 divided by 100 will bring my number to 8.68. So following along this way is going to make sure that you get used to setting up units and getting them to cancel. And I will tell you that we will use this process over and over and over again all semester. So the more familiar you are with this, the better. Do practice those extra ones in the handouts that I gave you in case you're still struggling with this. And I've also figured out what our tutor times are. Check the very top of this Moodle page and you will see when Gus Griffith, our student tutor, is, also when Miss Williams has office hours, as well as my own. So there really is about 16 hours a week that a chemistry tutor is available in 7213, the still. Okay, so moving on, significant figures. Remember the rules for this. Every number 1 through 9 is significant. Zeros in between non-zero numbers are significant. And zeros at the end of a number, if there's any decimal place, are significant. But zeros in front are never significant. Zeros at the end are not significant if there's no decimal. So in using those rules, count the number of significant figures. So in these, 1, 2, 0, 5, 6, 8, all of them significant. Decimal place, zeros at the end, yes, those are significant. Zeros in between are significant. Now here, 0 in between is significant, but the ones at the end are not, because there's no decimal. Here, 1, 2, 3, 4, 5, 6, all of them, and just those first 3, and then the last one, all 6. So hopefully you've gotten that. It's kind of clicked. Make sure you do the dynamic study module, both in the unit conversions as well as in significant figures. And I'm also encouraging you to go ahead and do the understanding matter and finish up chapter 1 post-lecture homework. All of those are related to chapter 1 and will greatly increase your confidence in understanding what we're doing. Rules and rounding. With multiplication and division, you need to know the number of significant figures. So you're going to round to the smallest number of significant figures in the problem. So in this one, you have 4 significant figures. In this one, you have 5 significant figures. So you know that your answer needs to have 4. In this one, you only have 2 significant figures. In this one, you have 4 significant figures. So you're going to definitely make sure that you round to where you only have the 2. Sorry, my number was terrible. That's a 2. Ooh, sorry. So that is a 2. Okay, so if I just take the numbers, I haven't done this, 120.1 times 2.0782. So my number comes out as 249.59182. So that's what my calculator is. That's clearly way too big. I have to go and keep 4. So start from the left, underline the first 4 significant figures you get to, and then that means everything else is going to have to get rounded. The next number is a 9, which means that it will round up, changing this to a 6, to 249.6. Keep the decimal place to make sure you're indicating the size. Keep the right size of the number. 25,000 divided by 233.7, I come out with the number 106.974754. Clearly way too big. I only want 2 significant figures. So the 1 and the 0, that means the rest of that ends up having to round. This 6 will change my 0 to a 1. Now I have 1, 1. I have to keep that 0 because I'm going from 106.974754 and I'm rounding up to 110. So do make sure that you keep a 0 at the end. Remember, zeros with no decimal are not significant, but they are still important to indicate the size of that number. I wouldn't want to round from 106 to 11. You've got to make sure that you keep the 0. Addition and subtraction, though, of course, does not run the same route. Instead, you're looking at the smallest decimal place. Sometimes it might be the ones, sometimes it might be the tenths, hundreds, the thousands. It wouldn't matter. You're just going to compare. So you'll do the math, but notice here I have 2 decimal places, 3 decimal place, 1 decimal place. So I'm going to round to 1 decimal place in my answer. With this one, I have 3 decimal places and 4 decimal places, so I am going to round my answer for the second one to 3 decimal places to keep the significant values. So 9,500.12 plus 3.066 plus 152.6. The number I get is 9,655.786. Remember I said that I've got to round here. So that means the rest of those are going to have to get rounded, and that is going to round this number up, 9655.8. Next one, 25.196 minus 15.1857. Do the math first. I get 10.0103. and I said I'm going to have to round to three decimal places. So 3 decimal places, that number is a 3, so it will round off, so it's just going to get dropped. But I have to keep that 0, so my answer will be 10.1010, keeping that third decimal place because of the math. So make sure if you need a 0, keep it. If you don't need the 0, drop it off. So we just did those other ones. So just as a review, I'm not going to do all of these ones. I think those other ones really did help in explaining this. But here, multiplication, this has 3 significant figures, 4 significant figures, 3 significant figures in my answer. This one, 3 significant figures, 2 significant figures, 2 significant figures in my answer. With addition and subtraction, 3 decimals, 2 decimals, 4 decimals, you're going to round to 3 decimals in your answer. Here, division, I have 1, 2, 3, 4, 5 significant figures on this side, 3 significant figures on that side. You're going to round to 3 significant figures in your answer. 1, 2, 3, 4, 5, 6, 7 significant figures here, 4 significant figures here, and that will be what I round to. So just covering those. These ones I think are the same as what we had in the PowerPoint, so just do those ones. Putting things in scientific notation or in standard form, remember that scientific notation would be to move your number so that it's between 1 and 9, and the exponents indicate the number of decimal places that are moved. So in this one, my decimal's here. I don't see it, but remember, if you don't have a decimal place, it always means it's at the very end. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 1 times 10 to the 14th. Tells you how many decimal places you moved. And notice that I do not keep any of those zeros because the only significant figure in that number is the 1. So if I wanted to put this in expanded form, so change this from exponents to normal, then I need to move my decimal place to the right 6 places. So 1, 2, 3, 4, 5, 6. I have to add 2 zeros to the end. 9, 5. 1, 2, 3, 0, 0. That's not, just no decimal place on there. Same thing here. 10 to the 12th means I need to go 12. So 1, 2, 3. So I'm going to still have to add 9. 1, 11, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so lots of zeros on the end there. If I see a negative exponent, remember that means that I have to go to the left by the number of, in the exponents, adding a 0 point. So if I go 1, that leaves me 5 more. 1, 2, 3, 4, 5, 9, 2, 9, 5, 2, 1, 2, 3 to extend it. Now remember with percents. So this one, I'm using exponents, which really makes you try to put these in your calculator. Remember that I told you about the button that is EE? The EE button, you can use that. The EE button takes the place of this part, and it includes that exponent. So for me to put this in for percent, I want to know 6.4 times 10 to the 4th is what percent of 1.55 times 10 to the 5th. So in this one, I'm going to take this as my part, and this is my whole. So remember that percent is equal to the part divided by the total, or the whole, times 100. So 6.4 times 10 to the 4th divided by 1.55 times 10 to the 5th times 100 is going to give me the percent. When you put this in your calculator, put 6.4, hit the EE button, and then the 4. It should be a positive. You should see that if you're in a graphing calculator, it'll show you a little E and then a 4. If you're in a standard calculator, or the kind that I use, you'll see that the number 4 will be smaller and slightly elevated in the right corner of the screen. That's displaying the exponent. Divide it by 1.55 EE and then put 5. So if you do this, 6.4 EE4 divided by 1.55 EE 1.55 EE to the fifth times 100, and I get 41.2903226. Oh, sorry, 258. That's the percent. Now, when figuring out correct significant figures, the exponent value is not part of your significant figure determination. This one has two significant figures, 6.4. This one has 3. So noticing I'm doing division, I have to round to the smallest number of significant figures. So that means that I'm going to keep the 4 and the 1. And the rest, 2.29032258, just rounds off. So it would be 41%. Okay, so double check that, go back over it. If you have problems with doing the calculation and figuring this out, please come and see me so we can talk more about it. Come to one of the tutor times. So in accuracy and precision, remember that we talked about the difference between the two. And so in accuracy, comparing it to precision, you should be able to recognize from a group of numbers if something is accurate or it's precise, as long as you know the actual correct answer. So in this question, you measure the mass of a metal 5 times, and you get the following results. Unfortunately, you're using an old weight scale, so you're not 100% sure, and you want to compare. So if you weigh the metal 5 times, notice you do not get the exact same answer every time. The key thing here is that the bottle states that the metal weighs 2.50 grams. So when you do the weighing, you get 2.85, 2.83, 2.16, 3.62, and 3.00. So in looking at these, 2.55, this would actually be considered the correct answer. So none of yours are actually that number. So if that's the case, then this would definitely be considered low accuracy. Not even a single measurement got a right answer. None of the answers were the right answer. If you had even one, you could say, okay, well, there's some accuracy that's there, but you would definitely say it's low because it's all over the place. And then since none of them are consistent, like I would say these two are kind of close, but really the other ones are really off. And so I would say it has very low precision. And I would be very concerned that the scale does not work correctly, because you may, if the scale worked but it was not calibrated, then you might get the same answer over and over and over, but it wouldn't be this number. But the fact that the numbers are so different all the time makes me think that that scale is actually broken and it's not consistently giving you any kind of read. So here is a density question. This is one that we didn't do in the lecture, but one that I wanted to go back over. So a tablet of Tylenol weighs 678 milligrams, has a volume of 0.17 milliliters. Determine the density with the correct significant figures in grams per mil. So remember that density is equal to mass divided by volume. And so things that we know, things that we don't know. So we know the mass and we know the volume. So we know these two, and what we want to know is the density. So we're going to use the formula just the way it is. The units, though, that they want is in grams per mil. So we want to have grams per mil. The problem we run into is we have milligrams. We have milliliters, so this one, we're good. We can check that one off, but we definitely need to do something with the mass to make sure that our answer is in grams. So 678 milligrams, we need to convert it to grams. Since grams is a base unit, we can do this in one step. 678 milligrams times and a line. Milligrams on the bottom, grams on the top. Milli means 1,000, grams gets the 1. Milligrams and milligrams will cancel, and that is going to change our number to 0.678 grams. So we can use that number, 0.670 or 0.678 grams divided by the volume, 0.17 milliliters. And we get 3.988235294 grams per mils. But you can't keep all of those numbers. Can't keep all those numbers. So here, this is division. Significant figures comes into play. 678, that is 3 significant figures. Even 0.0678 grams, 3 significant figures. 0.17, 2 significant figures. So therefore my answer has to have 2 significant figures. So the 3 and the 9, and that means the rest of those are going to have to round. So if this is an 8, that is going to increase the 9, changing it to a 0, changing the 3 to a 4. I need to keep the decimal 0 on the end to give me 2 significant figures. So my answer of 4.0 grams per mil would be correct. Like I said, if you have to have a certain number of significant figures, you may have to add a decimal place and keep the zeros in order to indicate the correct size. So the balancing equations is really the last practice. So remember, with balancing equations, the total number of each element on the reactant side and the product side have to be equal. And you do that not by changing the formula, but by changing the relative coefficients in front of each. So first step, I said, draw a line. Second step, make a list. Make a list of the total number of elements based on the formula. So then compare, find the simplest elements, which means elements found only in one place on either side. Balance those first, balance those that are found in multiple sides second, until they all come out. So in this one, SN, which is 10, SN, they're balanced. CLs are not. So over here I have 2, over here I have 4. In order to increase the 2 to a 4, I'm going to need 2 molecules of Cl. So 2Cl will give me 4. So 4 chlorines on both sides, 1 tin on both sides. That means these are just 1. Next one. Draw a line, make the list. 1 Fe and 2 OXY. I write oxy because otherwise that looks like a 20 to me. But you don't have to, but that's just what I do. Okay, so now in looking at this, you notice that neither of them are balanced. So the first one, if you want to balance the iron, I have 2 iron on the product side, so I'm going to need 2 iron. On the reactant side, 2 Fe's. They're balanced now. So now I look at the oxygens. So I have 2 on one side, 3 on the other side. So this one is lower. The only way, though, that I can make 2 and 3 equal is by thinking of the smallest number they both go into, which means I need to make them both 6. So that means that this has to get multiplied by 3 to give me 6 oxygen. This one's going to have to get multiplied by 2 to give me 6 oxygen. But do note that that's also going to double the number of irons. So now I have 4 irons and I have 6 oxygen. Those are balanced, the oxygens are balanced, but notice that I messed up my iron. So I've got to go back and balance the iron on the reactant side. Instead of having just 2, I'm going to need to double that again to give me 4. So that would be times 2, giving me 4 iron, 6 oxygen, 6 oxygen. Just change this to the number that it should be, and that makes it balanced. Next one, draw your line, make your list. Then go through, find the ones, they're all found singly, so you can just pick one. I just automatically usually start with the one at the top. So 3 irons here, 1 iron on this side. So I'm going to need 3 iron in front to give me 3 iron. Here, oxygens and hydrogens, I have 2 hydrogens and 2 hydrogens. I have 4 oxygens and 1 oxygen. So over here, I'm going to have 4 oxygens in order to be able to balance this. That means, let me change my color so you can follow that okay. So 4 times 4 times 4. So remember, 4H2O is going to multiply both the hydrogens and the oxygens by 4. So it's 4 H2Os. Doesn't change the iron because those are separate compounds or separate molecules. And now I've got 3 irons and 3 irons. I have 8 hydrogens and 4 hydrogens, so that is not balanced, but the oxygens are. So now I need to just go back at the end and balance the last one. So in this, to make 8 hydrogen, I need to have this multiplied by 4. And that 4 goes up in front. 3 iron, 4 oxygen, 8 hydrogen. So that means this is just a 1. Okay, last one. Told you it'd be a pretty quick review. I didn't think it'd be too bad. 1 phosphorus, 3 chlorines, 2 hydrogens, 1 oxygen. 3 hydrogens, 1 phosphorus, 3 oxygen, 1 hydrogen, 1 chlorine. Put a little bracket with the hydrogens on that product side because they're found in more than one place. Balance them last. So now, go back and look. Phosphorus and phosphorus are balanced. Chlorines are not. So I know that I'm going to have to change the product side. In order to have 3 chlorines, I need 3 HCl's. So that is going to multiply these hydrogens and this chlorine. These, the H and the Cl, both get multiplied times 3 in order to balance my numbers of chlorines. So phosphorus is balanced. Now chlorines are balanced. Before I balance hydrogen, check your oxygens, because oxygen's just found in one place on either side. So I am going to have to change the reactant side. It's smaller. To have 3 oxygens balanced, I need to have 3 water molecules, which means 3 H2Os. So 3 of the 2 H's and 3 of the O, giving me 6 hydrogens and giving me 3 oxygen. So now going back, phosphorus are still balanced, 1 and 1. Chlorines are still balanced, 3 and 3. Oxygens are balanced, 3 and 3. Here now I have 6 hydrogen, and looking at this, I have these 3 hydrogen and these 3 hydrogen, so they automatically balance. And I'll tell you that happens a lot. Leave the complicated ones, the ones found in multiple molecules on either side, leave those till the last, and they'll oftentimes balance themselves. So the ones that you have nothing in front of, it means that all you needed was one of those substances in order to have a balanced equation. So I hope that this helps. Go back over them. You have a balanced equation worksheet. Work through those. The answer keys are posted in Moodle, and that way you'll gain confidence in being able to balance equations quickly, balance equations, and not have to spend an awful lot of time on them.